Hello? Okay, I'm gonna try this kind of format because it's easier for me to just talk instead of typing everything out. Um, that way you can speed it up and all of that because I talk a lot. So, short answer to your question, and I will write this part out. We'll do 3D printing. Cardboard is harder to deal with than I anticipated. I just put together a half of a wing today in cardboard, and it's not pretty. So, and that wasn't going to be our final thing anyway. So let's just jump to 3D printing a little early. And I love what you have so far. So awesome. You have the Clark Y airfoil. I will say we'll keep that for now, but we might want to move towards a different one in the future. But for now, this is perfect. This is the one I told you to use, so awesome. And the reason that we might want to move to a different one is just the height here. We might want a little bit more height to make it stiffer, right? But honestly, we might not even need to do that. So we're gonna stick with this. Very great. So your extrude is 3.5 millimeters. Thinking about that in terms of like real scale, I know you're not in front of me right now, so you can't see the monitor, but that's probably, yeah, this doesn't scale because it's going to scale to your monitor, but like, that is probably close to 3.5 inches on my screen right now, or 3.5 millimeters, in real scale, right? So I always like to kind of zoom out and see what it's actually going to look like, because it looks different on computer than it does in real life. So anyway, having said that, I think that's fine. I think we can go even thinner if we extend the edges out, right? So I'm gonna make a branch. I'm gonna try to make a branch. It should have worked. Okay, I'm gonna make a branch from here. Don't worry about what this is. This is just me. I don't want to modify any of your work, right? Because I don't want to ruin it or mess it up. And I want this plane to be yours. So I'm going to. This is your work unchanged, and this is the new version of it that I created. Right now, there's nothing in it, so I'm going to go to. All I did was I'm in this one. I right-clicked on what you have so far, and I'm going to say Merge into Current Workspace, and it's going to take the B1 version, and it's going to replace your changes. So replace it with main, which is the extrude and 3D print and all that, instead of me having to redo it myself. Right? So this is still unchanged. This is yours. This one, maybe I'll title this something better than B1. And some people call this a fork. In like version whatever. Yeah, I'm not gonna go into that. Okay. So so great. We have a sketch, and this is exactly right. 100 millimeter cord. What I'm gonna do is up here. So there's all these different geometric constraints, right? And you know a lot of them. You know what concentric means. You know, like coincident does a whole lot of things, right? Tangent. You want to make a line horizontal or vertical. Like right now, this is horizontal, right? So I'm gonna click N to face the sketch fully. And so the black means it's fully constrained, right? That's great. So that means the length of that is fully constrained. But the position, you can still drag it anywhere. You can drag it only on this line, right? So maybe there's a coincident or a horizontal constraint between that point and this line, right? I'm going to add a midpoint constraint, right? So it's going to say the midpoint of this line, it knows that this line is 100 millimeters long. So it's going to find the midpoint for you by itself, and it's going to say, we want the midpoint to be whatever point I give it. So I'm going to give it this point. So all I've done is clicked on the point, I clicked on the line, and you can, the order doesn't matter there, you can click on the line and then the point, and then click midpoint. And now it's shifted. You can double check. If I want to, I can measure, this is the measurement bit, I can measure the distance between this point, and that's 50 millimeters, and of course the other one. Yeah, great. Okay, so that's not super important unless you're placing the piece, right? By the way, you could do this a ton of different ways, right? So that's how I chose to do it. If we want to delete that, right? So it hover. If you kind of hover up near it, it'll show the constraint, and you can literally click backspace. It deletes it, and now we're back to where we were, right? And so instead of that, what we could do is we could say, well, first of all, you could say you want it here instead, right? And so you can drag it along. I'm dragging it, so my mouse button is clicked right now, left mouse button, and then if I let go, this, you see the coincident constraint kind of pop up here? It's kind of hovering, and the point turns yellow and all of that. So that means that it's inferring that I want to make that constraint. Okay, so it's going to snap to it, right? So even if I'm not perfect, I'm still holding the button down, right? I'm just zooming in a little bit, right? So you can see even if that point is peeking out a little bit and it's not quite perfect, it will snap to it, and all of a sudden that it pushes it to be perfectly coincident there, right? And so again, this is now unmovable. It's fully constrained because we have a location and a distance and a direction. Okay, I'm going to delete that again. Sometimes you can't quite find the constraint. So in this case, everything is horizontal, right? Because this line's horizontal. And I think what happened was we made this point vertical with this line. Right, so now if I delete that, now I can be moving it again, right? So it's kind of weird how this works, right? So we can go again, instead of snapping to it, we can do that manually. We can say that wants to be vertical, or probably with the point is what happened, yeah. Right, and so that just means they have the same z values, right? We're in the z direction. Okay, I'm going to delete that again. If you don't want it to snap, right? If you wanted to just get it really close, and for some reason there's some reason that you don't want it to be exactly, you don't want to form a closed loop or whatever. When you feel yourself getting close, if you hold down Shift, your left Shift, then all of a sudden it stops showing up, right? And so now I can put it even closer than I put it before, right? Remember the purple was peeking out, and now if I put it right on there, there's no purple peeking out, and then I let go of my mouse button before I let go of Shift. Hard to see, but there's no actual constraint here. See, this purple is still purple, which means it's not defined. I've just shifted it over, but it's as if I shifted it from here to here, right? Except I just got it really close here. I mean, another thing you can do is shift from this side, and I'm not holding Shift at all. I'm just doing that, right? And so again, it's not going to do that because the thing I'm controlling is over here. So it's looking for things to snap to over here, not over here. All right. I'm trying to keep this video as short as possible. The problem with anything is I talk a lot, but the problem with Onshape specifically is there's so many little intricate kind of nuances like that, where I'm worried that if I don't explain it all, then people won't like I'm sure you're gonna use that everything I talked about eventually. You might not even know that you're using it, but it's something that has to be explained just so you gain an understanding of it. And yeah, okay, we're gonna build up the knowledge like that. So we have this now. Perfect. I wanted it to be in the center. It doesn't have to be, but that's what I wanted, and so that's what it is. And then we have the profile generator. You did this amazingly. If we wanted to, it's not facing the right way, we can switch it like that, right? So that mirrors this up and down, and left and right. Okay. Great. If you don't want to use the database, this stands for University of Illinois Urbana-Champaign. It's a very prestigious university for engineering, and so they have a ton of airfoils. This is not the full airfoil tools thing, but it has a ton of them. It has most of them, maybe all of them. You have single spline, so that's splining the whole thing. We're not even going to worry about that, actually. I won't even get to that. But I will get to trailing edge type, right? So you can see straight versus curved, and if I click on curved right now, whoa. Okay, for some reason it's not completing. Okay, I've never seen that before. Okay. We're gonna leave this as straight for now. On every other one of these that I've worked with, the same profile generator, just every other different airfoil. If I click, let's say, if we make this, no matter what I have in the bottom here, it doesn't look like this. It looks like a full curve, a full like point. So usually it's a trailing edge, right? So we want it to be sharp, and this is definitely not sharp. It looks sharp because when you zoom out, it looks sharp, sure. And it's sharp enough if we were to 3D print it, probably, because the printer's not going to be that precise. But for things that we need to do, we'll see how this works. Okay, I'm going to delete my changes to what I did to your thing. Now there's two things. What? Why are there... Okay. What's going on here? This is what I meant, by the way. Right? So this is a single spline, right? And so it's taking... when I say spline, I'm going to hide everything for right now. When I say spline, I'm talking about this curvy thing, right? And so I can draw it, and the main parts of this, you notice how the change, this changes behavior when I connect it or don't connect it, right? If I put it really close, right? So this is another example of why you might want to not snap it, right? So I'm holding shift right now, and I'm getting, still wants to shift. Okay, but I'm getting it closer than I was. Alright, this is really weird right now. So the main points of the spline tool is you can change the position of these points, right? And you can change their slopes, right? So we talk about slope, right? This is just a point in space, but it dictates where the points next to it on the curve go, basically, by its slope, right? And so, you know, if we bring its slope down, these are like little handles that we can drag, then the whole thing changes the thing. But the main important bit is, like, this is a curve. It's very curvy. There's no sharpness to it, right? And that's because the other part of this is these slopes have to be equal at some point, right? So this one slope has to be tangent to the other one. It's actually fairly simple to code, but it's not necessarily so simple to even think about. Right? So people, you know, graphic designers spend some time learning how to use this, because sometimes it does unexpected things, right? Anyway, so when we say single spline versus double spline, right, what we could do is, if I connect this right here, it doesn't like it. I'm going to start over and make a new spline. And by the way, there's two types of splines. We're going to work on this one for now because it's just the simplest. I'm going to make one. I'm going to make a real airfoil, because why am I being abstract here? There's no point. So I'm going to make the trailing edge right here, and the leading edge will be somewhere to the left. Right? So it's going to be the simplest airfoil in the world. It'll be like that. Maybe there'll be one there and one here. Right? As soon as I connect this, if these points aren't close enough to the end here, then it's going to make this kind of this smoothness to it, right? And the further I drag these points, the sharper it'll become, right? Right now it's trying to snap this so that that goes horizontal. I don't want to do that, so I'm gonna go like that, place it wherever I want while I'm holding Shift, and it's good, right? And so now that's gotten pretty sharp, right? It's still curvy, right? Because it's always going to be curvy, because that's the point of the spline. But it's much better. It's fine for what we're doing, and then we can change the shape. We can add more points in here if we don't have enough points anymore. But there we go, right? So that's one thing. If we don't want to do that, what we can do, so I'm going to do the same thing on the other side. It's going to be like a mirror image, except that I'm not very good at drawing, so it's not going to be. But actually, I'm going to stop. So this one had 1 at the end point, plus 2, 3, 4, 5 points, right? So I'm going to do the same thing. I'm going to have 1 end point. Actually, this will be the same end point, right? I'm not even going to. So there'll be 1 here, 2, 3. We'll try this. I don't know why that's there. And then I'm gonna do it in 2 separate splines though, right? So then I'm gonna have another one here. Oops. 2, 3. And because they're sharing these ones, then it's 1, 2, 3, 4, 5. Right? I accidentally made this horizontal with that, which may or may not be what you want, but for now I'm gonna take that out. And so you see this, right? And so we can change this to however we want, and we can make it not nice, but we want to make it an airfoil, right? Which means that these two have to be tangent to each other. Right? So we're going to use this tangent function. I'm going to say this curve is tangent to this curve. Okay. When we do that, the whole curve is tangent, and it doesn't like that. What we mean is just these 2 points, right? So you could go this handle be tangent to this handle, or to this curve, or actually what we're going to do is just coincident, right? So this handle is coincident to that handle, and now they're going to be in the same line because there's 2 lines. The only way for 2 lines to be the same is if they're in the same line. And there we have it, right? So we're going to move this maybe down here. Maybe we want it, if we get this away from it, it'll smooth it more, right? And then let's see what else. We can go like that. So we have a little more control now, right? Bring that, and this, the main thing though, besides the control, right, is the sharpness, right? Which is more aerodynamic and it's more of what we want. However, it doesn't really matter when we're 3D printing, right? Because in 3D printing, it's going to end up being a curve anyway, right? The printer is going to come here, it's going to do this line. It's not going to like stop and like come from somewhere else and do the other line. It's just going to go like that. And if it's going really fast, then that looks like a curve, right? I mean, maybe it rounds it very nicely. Our printer is very good. But it's you know, it's not good enough, right? So it'll look more like this, right? And we can sand it down and make it sharper later. So that's a pro for this thing. Maybe. Aerodynamically, again, we want it to be like this, right? However, and the reason for that is you have air going over this. You have particles, individual particles, right? And you're gonna have this boundary layer, right? So you have air coming in here. It wants to go around like here, right? I'm not worrying about any of these constraints or anything like that. So it wants to go like that. There's some particles that are going to go the other way, and but the main point is they start out, you know, relatively the same air over here, and they want to finish the same here, right? So they want to meet up with each other, and the only way to do that is, or the best way to do that, the most efficient way to do that is a sharpness here, right? You want to give it enough time to separate. You don't want to separate it too much, right? You start going like this. It's funny, actually, some of these constraints kind of work, but don't. This is not a real physics explanation, so don't get. I'm getting way off track. If your airfoil looks something like this, then the air is going to just go over it, and it'll go into that bump a little bit, but there's going to be separation here, right? And so the air isn't gonna, it's gonna be kind of a blank space under here, and that's gonna provide a lot of drag. I might just cut this. But the main point is there's these 2 different types, right? And specifically, these 2 different types exist philosophically, of course, but they exist also as tools in this profile generator, more importantly, right? And so, again, we want the sharpness, but if we use the sharpness, and I remember showing you that you know, this loft tool was acting weird, right? So we're going to talk about loft again. Okay, I messed that up. What? Okay, so again, lofting is taking this and going to there, right? It would make some solid body out of that. And if you think about it, right, you could do that infinitely many ways, right? Because this geometry is, even if it was fully defined, the way in which it does this, right, you can have it follow any type of curve. But we're gonna try to do this as simply as possible, right? So it'll take maybe I don't even know the algorithm. Maybe it's just like the least distance from this point to this point. It makes a straight line, but then it has to have the exact number of points from here to here, right? So it does some kind of algorithm, and you have that. If I had some sharpness here, and I tried to do that, it might be fine for the first little bit. So sorry, I got kind of, again, this coincident. Alright, that's a pretty ugly looking airfoil. Okay, so it still works when I'm trying to show you it not working. Okay, if I click this, does the recording? Okay, if we're still recording, this is when it doesn't work. So this is a propeller design that I was working on last week, and it's done basically. But all I was trying to say, so maybe I should just cut all that. All I was trying to say was it's taking a second. The profile generator, same thing, right? You choose your plane, you choose your points. Awesome. I'm using the NACA instead of the database. You might be able to find a NACA airfoil in here, the right one, but it's easier if you just, yeah, these are all NACA, 0404. So if I click this versus if I type in 0404, it should be the same thing. I chose upper and lower splines. The main thing I chose was curved, right? And this was not working for a long time until I chose curved. And so that's basically the sharpness here. It keeps it as the geometry, right? Because that's what the wing actually looks like. And then it adds this curviness here, so that it's not a sharp point, right? A singularity is what I would call it, right? So the loft, however the loft does it, it's going to take all of these points and map them to something over here, right? Which means mapping every single point between the space from here to here, right? And you can do this for many different profiles. So I did it for 10, probably too many, but it goes from here to 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 here. And it would not work with the singularity here, right? Because the it's trying to kind of match slopes and positions in all different dimensions, and it just doesn't like it. So anyway, loft, if you ever have a problem, and honestly, in a lot of CAD, if you just ever have problems, it's probably because of some sharp points or some self-intersection. So that's what I had to do. This is a propeller that I've 3D printed. It works decently, and I will talk about this a lot more sometime. But for now, back here, aren't you glad I made my own version now? I'm going to go ahead and delete all of this, and we're going to show your part. and get back to it. So, sorry. If you don't want to see these dots, you can hide the sketch, but it's not a big deal. And again, this is some weirdness. I've never seen that before. So we'll see if this works, or we can move to a different airflow. It's not a big deal. So we have that. Great. I'm going to make that a little thinner. Maybe 1 millimeter. If we can kind of just extrude the outsides of it, right? So I'm going to click here. I'm going to make a sketch. I realize I've been talking way too much, so I'm going to try to do this very, I'm not going to explain so much. I'm just going to do what I'm trying to do, right? So I mean, I will explain a little bit. Okay, I'm not. Okay, doesn't like that. Oh, at that distance. So I created a sketch on the face, and I'm trying to offset this profile, right? So maybe another thing about offsetting and just sketch tools in general, there are tools like mirror, for instance, or linear pattern, or any of these things. Fillet is right here. Almost all of these things are better in the 3D version, right? Sometimes you can't get away with using it, but I absolutely hate using mirror sketches. I will rather just. Oh, this is me talking too much again. I would rather, if I had to make some kind of shape, I'd rather make that shape again on the other side here, and just put in the necessary, dimensions and geometry constraints. Like I can make this, I can make this horizontal here, or whatever, and keep doing that. I'd rather do that because this thing is not modifiable at all. Right? If I do this, I'm going to select the mirror line to be this thing, and go like that, and that's it. Right? I can't, once I click out of it and I click something else, I can't change this, or I haven't found a way to. Right? You see these constraints, and that's great, but then I can't double click to edit. Yeah, I can't double click to edit, oh, edit this mirror line, or edit what I'm mirroring, or whatever. Okay, sorry. And so you can do that too. You can use mirror outside of sketching. Okay, we're back. So offset's the same thing. You see this constraint, but that's all you see. But we're not going to worry about it too much. I'm going to go with, I want it to be on the inside, and I want it to be like 1 millimeter or less, right? So I don't know how to get it on the inside, and this is exactly what I mean. Okay, that didn't work. So this is exactly what I mean, right? I cannot. You can drag this. I cannot seem to get it to modify this offset. So I'm going to delete the whole thing, right? That's what you have to do. You have to start over. I'm going to do the same thing, and I'm going to click this button to go onto the inside of it. And it doesn't like that, but I think that's because of the distance it is. So I hate this so much. Okay, offset failed. It's fine. So I don't have to delete anything because it failed, right? So there's nothing to delete. But I'm going to click it again. I'm going to click what I want to offset. I'm going to make it 1. I don't even know how to type it in. Do I double click this? Make that 1. But now I can't click the other thing. This is a professional engineering tool, guys. Okay. Go that, and so it doesn't like the distance, but I can't change the distance because... Okay. Very disappointing on shape. okay, again, I said, you know, I was preaching, oh, we'll use the 3D version of it. We can go ahead and do that. We shouldn't have to, but I'm going to take this edge, right? So this is an edge of a three-dimensional object. It is not fully enclosed, right? It's just one continuous line. You can see the length of it. It's 204 millimeters, right? So that's great information. If I wanted to create, you know, if I wanted to wrap something around this to make a wing, right? If it's super long, like a piece of cardboard or whatever, I know that the circumference is 204 millimeters. So I'm going to take this, I'm going to extrude it, and you're going to say, well, how are you going to do that? It's not really something you can extrude, and you would be right. For some reason, they think it is. Okay. It thinks I'm trying to extrude the face. And that's not a sketch curve. Okay. I'll create a sketch. On this face, I'm going to use the edge here, right? All I did was I said I want to basically create a sketch of whatever I want, right? Again, I don't want to go super in depth, so I'm not gonna. I would show an example of use. I'm not gonna get into that, but please ask me if you want to learn more. I'm gonna go to extrude. I'm going to click the sketch. I'm gonna use the surface, and there we go. That doesn't look like a surface to, oh, it does. Okay, good. So there's no distance between these. Okay, backing up and slowing down a little bit. Once I had this line that I liked, right? This is just from your profile generator, and I guess it did include this. It's fine, doesn't matter. You can extrude a solid body, right? Which is this one, right? This is your first extrude that you made. That's great. It created a new solid body, and that means all the solid body means is you can, if you wanted to, you can 3D print this right now, and it would come out exactly like this, 1 millimeter thick, and all that. This is a surface, right? And so it has no thickness to it at all. If I tried 3D printing this, you know, export as an STL, it would just, I think it would show up as a problem when I tried to actually click print, because there's no substance to it, right? It's just kind of a mathematical tool to represent position and like a set of points, right? But a point, again, right? A point is non-dimensional. It doesn't have any substance to it at all. Right, so this is just a collection of points, an infinite collection of points if you think about it. So we're going to use thicken, and now we've turned this surface that, you know, is non-physical into a real thing. So if you're trying to thicken it too much, right? So I thickened it on the outside. It was completely fine. Oh, okay. It's completely fine with 5 millimeters, right? You can thicken it however much you want, because it's not intruding on itself, right? And so that is kind of a crazy thing. But if you look at it, right, if you pick a point over here, the corresponding point here is exactly where it should be, right? And if you were to kind of extend this all the way, you can see that this first nose bit, I think, should be exactly the same geometric shape as this nose bit. I don't know that for a fact, but it's kind of starting to look like it, right? You can kind of imagine. I'm gonna go back to 1. I'm gonna change it to the inside, right? And now the inside is kind of fighting against each other, against itself, right? Because if it starts intersecting itself, oh, it doesn't like 1 millimeter. Okay. Dang it. Okay. So it doesn't want to intersect itself because, right, so that's the thickness right now. It's, I think it's 0.01 millimeters, which something is weird. But if it starts intersecting itself, it doesn't know what to do, right? It kind of freaks out. We're gonna keep it as that. I'm gonna go back into this and I'm gonna delete this part, right? So that edge still exists, right? But in this sketch, it's not a line, right? So this sketch, this is a line. That's what the use function did. And I only want to use the curve. I don't want to use this bit. This is kind of the tail of this is all weird. So I'm gonna go back to thicken because somehow it reverted to 5 millimeters. Change it to 1. Change the direction, and it still doesn't like it, right? Because you can see. Let's go with 0.2 millimeters. It's doing some weird stuff here. It's doing some very weird stuff. I don't know what it's doing. Okay, that's what we want, right? But because of this, it's being very weird. This is exactly the engineers will blame the CAD software and the CAD software will blame the engineers. It's probably both of their faults, but people grapple with this like as a job. Like people get paid to just tear their hair out about stuff like this. So real engineering, yay. We have now created, so we had to go to 0.05 millimeters, right? So first I went to 0.01 just to make sure there was a floor, right? That this thicken was even possible, like physically possible with their algorithms. And it is. And so I try to increase it as much as I could. Maybe 0.06 will work. Nope, it doesn't. Right? So this turns red. That means it doesn't like that. Right, so we're going to go to 0.05 and that makes it happy. There's a better way to do this. But I think that maybe the easiest way is just to get this sorted out. The sharpness here, right? So now we have 2 singularities instead of the 1. I don't know how this happened. But again, this is not my point. So we have a thickness now, right? We could 3D print this part, and it would not turn out very nice, because the average width that we 3D print is like it's around 0.5 millimeter, right? This is 0.01 millimeters, right? So that's 1/50th the, can't be right, 1/20th the width that we want. 1/10. Wow, I'm really bad at math. So also we can extrude this less. Like we don't need that much. But again, this is if I wanted to do this, I would have, or how do I say this? I want you to do this anyway, right? So this is me walking through it for you. In your case, like if you want me to walk you through it more with you, it's totally fine. But in your case, I would first fix the tail here, and then we can kind of talk about it. And so how I would do that is probably, mess around with these, right? If none of that works, see, now we're seeing what I expect to see, right? Problem is when you change something up here, sometimes that messes with everything down here. That's totally fine. Don't delete it. Don't go ahead and just shoot these things as your first instinct, right? What's happening is it's saying it's missing the face of the profile generator, right? You changed this thing, and so now it's like you replaced it with something new, and it needs to know what you replaced it with, so you can easily take that out and replace it with that. Right? Great. I'm gonna hide that again. This is already looking much better. I don't know why I didn't just do this to start. Sketch, we're going to sketch that. What was the sketch? So the external references here, this is use, right? Again, it's like projecting on the plane that you're sketching on. It is projecting whatever you tell it to, right? The shadow of it, right? And so it's missing here because, again, that was an old like body, and now this is a completely new extrude because we've updated it, right? And so we're gonna go ahead and again, I'll go ahead and delete this whole thing, and then click use again. Boom. Right? You won't always have to be updating this like this, but for now, that's where we are. Now it's missing that, so we'll go ahead and the merge. We want to merge it with this piece that you made before. That works. And let's see if we can get away with thickening it. Great, let's do a millimeter. Okay. Sorry, again, this is not behaving. So it likes that. That seems a lot more than 1 millimeter to me, but I guess it is. I'm going to try to thicken it in 2 different stages. Right? And so now it's not having this intersection problem, right? So you can see the problem that it was having before, right? Obviously, or not so obviously, but this intersects with that one, right? And so it doesn't like that because it doesn't know, what are we double counting this region? Like, what do we do there? But now when we do it as 2 separate things, then that's okay with it. So maybe a 3rd separate thing should work. No. So this still doesn't work because it's doing that within itself now, right? So let's see if I can show you, right? So with 0.5 millimeter, it's fine with it. with 1 whole millimeter, it ends up encroaching these corners here. I think end up encroaching on each other. So we'll bump it up to see how far we can go. Right, 0.75 works. 0.8 does not. Right, try 0.7 works. So then 0.73, 74. I hate that you have to do this, but it's kind of where we're at. And that's basically filled. Right, there's a little sliver right here. Don't get too hung up on this type of stuff. I might come back to this and figure out a better option, right? So this is one way to do this, what we want, but there are many better ways to do this. This is just what I thought of. But now you have 3 different parts, right? We have the surface still. We don't need that anymore because we have the solid bodies that we want from the surface. But we have this surface, or sorry, we have this part. So that's your original extrusion plus the top. We have this bit, and we have this bit. And honestly, if we went here and clicked add instead of new, we merge it with your first bit, then okay, that likes it just fine. Okay, so within thicken, it doesn't like it, but if we do that, so instead of new, we're adding it, and we're merging it with just the existing body already, then it's great. It looks like that's closed up, so awesome. So think about how, like, this is 1 millimeter right here, so it's gonna look more like that, or however big a millimeter is on your screen. It's not very tall, right? So it might not resist some serious bending. Again, we'll see. It'll be fine. We'll use this for now. So we have this. The reason I had this rib right here, the whole reason I went through all that work, and again, not again, but looking at this now, the better way to do this, right, is to make it slightly bigger than, or not make it slightly bigger, extrude the whole thing and then cut out a section, right? So we can do that next time, or maybe I'll make another video. Notice how this is sharp and this is not sharp, right? This is not sharp because of CAD, right? We kind of need it to be not sharp, and it's fine if it's not perfectly sharp. This is sharp. Again, in 3D printing, it won't be, but it'll be decently. It'll be sharper than this, and that's fine. Again, we don't care, but it's interesting, right? Actually, we kind of do care. Well, no, we don't care at all. It's fine. You have this. Well, great. We don't have to, but I want to do the same thing to the other side. Except I don't want to do all that work. So what we're going to do is mirror. We're going to mirror. It's going to be a feature mirror, right? So if we want to mirror the part, we can mirror the whole thing. Well, we could maybe do that. The mirror plane would be this. Yeah, okay, that works. And we want to merge it, right? So, we want to merge it with its first half, right? So I created its own clone and then glued them together, right? Because it's add, not new. Right? So this is a new thing. That would make 2 separate parts, and we can glue those together separately if we want, but we don't have to. We can do that here. Okay, so notice that the distance between this part and this part is 2 millimeters, right? Your extrusion, your initial extrusion is only 1 millimeter. So obviously, all it says is you mirrored the extrusion as well, right? So that's fine. I think that's a better part in general. Now, let's talk about actually 3D printing this, right? So, sorry. Let's talk about why I did this to begin with, right? We could totally have printed the original thing, right? This is the distance between this bit and this bit, right, kind of that distance, is 8 millimeters now, right? We could have gone ahead and instead of changing your 3 millimeters or whatever, sorry, just for ease, I'm gonna, or actually no, I'll show you a thing. I'm gonna pretend like none of that happened. So we're back to your thing, and instead of 3, or instead of 1, we're gonna choose 8 instead of 3.5. Right? That could have been the same thing, but this is pretty heavy now, right? We can, if we're 3D printing this, a lot of the times when we're 3D printing, we're not printing 100% infill. Like there's some air in this, right? But even when, like, even with the air, it's still a pretty heavy part. Because whatever you're doing on the inside here, you're doing for the whole 8 millimeters, right? So all this being said, I just want to do that. The reason we want to make it wide is for alignment and all of that, right? You imagine if it was paper thin and you try wrapping something around it, it can easily just collapse to one side or the other, right? Let's say we're wrapping something around it, and then this just all the way goes all the way to the left or to the right, right? There's nothing really holding it up. Now it's got some feet to hold it up, right? Or hold it in all directions, not just up. So there's that. The reason these are 1 millimeter is because that's kind of the smallest we can get away with. We can go with 0.5 millimeter, probably be fine. But it wouldn't save a ton of weight. Let's see. And that's about it, right? So that's kind of decent. Remember, this is for a flat, a rectangular wing, right? If we were doing some kind of elliptical wing, then it can't be straight, right? We can't do a straight extrusion. It would have to be some kind of loft, right? Because this would be bigger than this, right? It's going towards the tip, it's getting smaller. So much more complicated. We will come to that, but for now, this is a great start. To 3D print this though, I don't want to lay it flat like this. Hold on, I'm actually this is already an hour-long video. I'm sorry. I'm gonna make another quick video in the 3D printing software. Very quick, very quick.